Hello, welcome. My name's Eve Boyce-Ratliff, and I work for Upstream Tech. And we are lucky to have Paula Nieto here with us today for a conversation about the importance of high accuracy land cover data. I'm super excited to have a chance to have a conversation about that topic, as I think it's probably quite relevant to many of you and the work that you all are doing. Just before we get started, a few housekeeping things. One is that we're recording this and we'll send out the recording after the webinar. So if you are interested in passing it along to colleagues or you want to watch it again, just know that that's coming. And if folks registered and weren't able to attend, like other people on your team, they'll get that recording as well. So it will be widely disseminated and feel free to share it. We'll be taking questions at the end. We'll have a little time for Q&A, so feel free to drop questions in the Q&A box. It looks like some folks have already said what organizations they're from. Hi, everyone. So yeah, feel free to drop questions in every time. I'll kind of facilitate the Q&A session at the end of our conversation. But let's get started with just a quick introduction. So I'll introduce Upstream Tech, and then we'll hear from Paula. We'll have some time for just sort of a back and forth between us. I will jump into Lens quickly towards the end just to show you what it looks like, especially for anyone on the call who's a current Lens customer and who wants to be able to access this data. I'll kind of walk you through what that process looks like. And then again, time for Q&A at the end. But Paula, thank you so much for joining us. Excited to chat with you shortly. For folks who aren't familiar with Upstream Tech, we are a software company, but our team is made up of both software engineers and also people sort of across the conservation and science space. So we have people like me whose background is in conservation work. I used to do land conservation work. Basically, I used to call it real estate for the environment. But we have hydrologists on staff, meteorologists, and we have two products. One is Lens, which we'll be focused on today and which many of you are probably familiar with. The other is Hydro Forecast, and it's a streamflow forecasting tool. So taking a lot of the same remotely sensed inputs that we'll be talking about on the call today, but putting them into a machine learning model that then's predicting how much water will be in rivers. And that's used by hydropower companies, conservation groups to understand how to optimize the management of rivers for flows, both for energy production, but also for things like fish passage and habitat creation. And so there's sort of a through line between our two products, which is that we're trying to help people better manage land and water, and that also we use remotely sensed data in the work that we do. Lens, for those of you who are not familiar, is a remote monitoring platform. So we are aggregating data from a bunch of different geospatial providers, including companies like Space Intelligence, and helping basically translate that data into answers for questions that people might have in the work that they're doing around land and water management. We sort of see a need for a role as kind of an intermediary to help take this really amazing data that's being created and put it into a format where it's super efficient, quick, and easy to use for people who are maybe not geospatial experts in their day-to-day, but would find value in having answers to questions that can be answered with geospatial and remotely sensed data. And so we work with a whole bunch of different partners. You see Space Intelligence on this list. There's a bunch of others as well, and try to make it easy to access the really important work that they are doing for basically conservation and land management purposes. And part of the purpose of having conversations like this is we also see our role as trying to facilitate greater understanding for, the importance of data, how data is being created. Sort of sometimes we use the phrase the promise and pitfalls of different types of remotely sensed data. And so having these types of conversations and interviews is hopefully helpful as people think about the way that they can leverage these really powerful tools in the day-to-day work that they're doing. These days, we're working with over 250 organizations on the Lens side, monitoring over 140 million acres, so a pretty big footprint. I think it's across almost every continent, if not every continent, maybe not Antarctica. And you'll probably recognize some of the logos down there. We work with many of the leaders in the conservation and forest carbon sector. And we work with our partners in a couple different ways. Some of them are just accessing our platform directly. So you'll get a chance to see a little preview of the Lens platform. Some of you might already be Lens platform users. Many of our customers are basically using sort of our self-serve, off-the-shelf platform to access data, annotate information, generate reports, and you'll see what that looks like. But we do also have a professional services arm where for our customers who maybe don't have the capacity or interest to do monitoring in-house, we actually will do that on their behalf and basically provide them with insights directly. So there's a couple different ways that folks are working with us. And I will say sort of a third area that we've seen interest and is relevant to this conversation is we do often serve as sort of an ad hoc advisor for our partners in, what's the appropriate use of different types of remotely sensed data? Where is it exciting to use sort of one source or over the other? And because we are partnered with so many different options, we sort of have a nice 10,000 foot level to be like, this is the appropriate use for this. And I'm excited to dig in with Paula on how she sees the space intelligence data playing a role in both the carbon and conservation spaces. So with that, actually, let's transition. I have already spoken too much. This really should be a conversation about Paula. Let me just quickly introduce her because I know people sometimes are shy to say their particular credentials. I won't make her do that directly. So I'll introduce her and then we'll hear from her a bit about what space intelligence does. But Paula, thank you so much for joining us. We are very lucky to be joined by Dr. Paula Nieto. She is the head of science for space intelligence and has over 15 years of experience across a broad range of remote sensing topics, including specific expertise around mapping and monitoring tropical forests. She has a PhD in forest carbon from the University of Edinburgh and a master's in science in GIS and remote sensing. So all that is to say, she's an expert in this space. She knows a whole lot more about this than I do. And I'm excited to pick her brain, and she can tell me if my questions are completely ridiculous and stupid. That's always really helpful. So yeah, really excited to have you, Paula. Thanks so much for joining us. And so I guess to start out, if you could just tell us a little bit about, the history of space intelligence, how it was founded, and what you all do.
Yeah, thanks, Eve. Thanks for the really nice introduction. And thanks for inviting me to join this webinar. And thanks for everyone that is attending. So yeah, space intelligence, we are a nature tech company producing high quality nature mapping datasets, including maps of land cover and carbon stocks. We mainly support nature-based solution project development, investment and monitoring. We have mapped currently about 50 billion hectares. I don't know in acres, sorry, I work with hectares as we are based in the UK. But this is across more than 50 countries, and you can see it here in the slide marked in green. And we continue building our catalog of maps that we are mapping. We work with some of the world's largest companies and project developers. For example, we are part of Apple Restore Fund, working together with Upstream for the past few years.
Awesome. And what was the impetus for space intelligence initially being founded? What was the question that your founders were trying to answer, or sort of the opportunity gap that you saw where the work that you could do could fill in?
Yeah, so the company was founded by Ed Mitchell and Mary Collins in 2018. They both have a strong academic background, and they were tired of looking at the forest destruction, so wanted to do something more active about it. So that's why they founded Space Intelligence, and why, as we are strongly backed by science, our mapping processes leverages decades of experience and research. So we have published more than 100 peer-reviewed articles on land cover and biomass mapping. And we have around 13 employees with relevant PhDs. And about the team, I think we all share like a passion for conservation and nature and forest. Our expertise underpins what we do. We have a very talented and multidisciplinary team. We are a mix of data scientists, geospatial and machine learning experts, engineers, and ecologists as well.
They have an exceptional number of PhDs on their team, I have noticed.
Yes.
A lot of experts in the field. And I guess I'm curious, sort of, what are the main problems that you see space intelligence's data solving for? And let me know if you ever want me to move ahead in slides, if that would be helpful.
Yeah, I will let you know. I think at a very high level, the main problem is the lack of trust that customers now have in forest conservation and restoration projects and all the carbon markets. And that's what we are trying to solve. So we take the accuracy of our products very seriously, and we try to work with project developers and corporates to report their impact on with a high degree of confidence. So that's why our map, we call them our audit grade, because they can help project developers and investors pass an audit and help them to invest in projects with the confidence that these projects are really making an impact. So I think this overall helps provide integrity to the carbon markets.
And what is the difference? And sorry, I'm going a little bit off script here, but want to dig in on this a bit further. But how do you see the difference between sort of maps that might be similar around land cover that are available globally and the kind of work that you're doing? Like, is there something different about the process in terms of how you're making this data that leads it to a different outcome than a global land cover map?
Yes, so I think the main difference, well, there are many products out there and many of them are great. It's difficult to filter all of them out. The main difference is our products are locally calibrated. So we either create them for specific project areas or regional areas or at a national scale. We don't have like a global map. And this provides many advantages for the accuracy of the map because we take into account the local calibration, the local ecological aspects of a specific area.
Cool. And can you talk us through, there are 4 different data sets here. What are the different ones and how are they used?
Yeah, so this shows our 4 main data sets that we have. So we have land cover, carbon stock maps. We also provide monthly degradation maps and deforestation risk. And together with them, we provide insight reports for clients to see the impact of a specific project. Sometimes we might use only land cover maps for specific cases or a combination of all these 4, sorry. It depends a lot on the use cases, but we all do it at a national or regional scale.
Cool.
And what we use for this, I think I added in the slide some use cases of how we use this data. So, sorry, previous slide. Yeah, thank you. So I think these are some of our users' cases, which include support in all stages of a nature-based solution project. So from project screening or pre-project selection. So this is like to help identify areas that are suitable for a new project. For example, for a red project, we can identify historical deforestation. We also help with origination and baselining, so we can provide our habitat and our carbon stock maps as appropriate depending on each methodology that they want to use and estimate the baseline conditions. And we also can support actually the collection of field plot data and help through the audit process.
Cool.
We also help due diligence for investors, providing data and assessing the quality of the projects and ongoing MRV for forest carbon projects like REDD+, ARR, or IFM projects.
Cool. I'm really interested in the monthly degradation data because I think that's an area that I've been hearing come up a lot more just in the last couple of years around, you know, preventing deforestation is super important, but what about this issue of degradation and how do you, you know, that's just generally harder to detect using remotely sensed sources. What does that look like in terms of the data product? What's your sort of definition of degradation and how are you creating that?
Yeah, so this is actually a new product we have. We have been working extensively on this for the past year, and we have experts that have been doing their PhD on this, so now we are delivering this as a product. And what we can do is create like alerts of degradation where it's not only the change totally from a forest to a non-forest class, but it's like a loss of that forest, of carbon stock in that forest. And we do that both combining, well, I can speak later a bit about how we created our data, but one of our strong facts is that we use both satellite and optical data. And we use this also for mapping degradation. And this proves really useful around the tropics. Some other data sets might only use one optical or mainly. So this helps us provide a better quality data.
Cool. Yeah, let's actually get into that. I would love to know a little bit more about how you're actually creating this data. I think the way you do it is a bit unique. Should I go to another slide?
Yes, you can go to this is an example, maybe go to this one, yes, because this shows exactly how our process looks like. So here we have the diagram of the process we use. We gather all the satellite data we can use to map an area. This includes optical, LiDAR, and radar satellites. And we typically look at an individual pixel or area of the world over 200 times a year. So this is like a lot of times we gather all the data that we can use. And this gives us advantages of seeing an area in different wavelengths and integrating information from different times of the year. What we do with this is we combine it with field data and ecological knowledge and analyze with advanced machine learnings and human-in-the-loop ecological knowledge for this. So we have our in-house ecological expertise. We create area reviews and collect data calibrated to a specific area. So that we incorporate local calibration to capture regional factors, such as, I don't know, natural forest definitions, national, that might vary different countries, the types of forest, seasonality of the forest, and topography or elevation. We put all this into our own machine learning framework that has been set up to capture these localized differences and regional trends. And as you can see, we did this as a circle because this is quite an iterative process. It's not only one go and then that's it. We have accuracy assessment process and reviews. So we do this many times and improve the map as needed. If we see that an area is underperforming, we might ask our ecologists to collect more calibration data in an area until we are happy with the accuracy as the output.
Cool. I think that the sort of human in the loop piece is one of the things that makes you all differentiated from other people who are creating data like this. And I'm curious how you landed on the need for that. I mean, obviously, it would be a lot more efficient if you could just run your models and not have to have people involved. What's the sort of business case for why you all feel like that's so important?
Yeah, totally. It's actually really time consuming, but I feel it's critical to better understand an area and not just trust a machine learning model with it. You have to really understand the ecology of an area, what is happening. And that's why our ecologists are so important. And also that's why we create a forest and non-forest map, we normally create land cover maps. So even with forest, we might map different types of forest. I think I have an example in one of the slides. You can go to a slide I have. Yeah, that's Indonesia. So we map the whole country of Indonesia. You can see here we did with 8 classes, and I think 3 of them are forest classes, including forest, dense forest, open forest, and mangroves, and plantations. So we help to differentiate these classes, and this is very useful because then we can check whether it's actually a forest has changed into a plantation, which is still tree cover, but then it's not a natural forest. It has been deforested. I think this map, for example, we did for 2 different years, 2014 and 2023, so we can see the history of it and the deforestation, and we did it at 10 meters. We're talking before about other types of data sets and how they might work in an area. For example, here in Indonesia, most of the deforestation was very large scale, mainly deforestation for plantations. I think it accounted for at least 70% of the deforestation. And we saw that our accuracy really outperform other classes. I think I have other slides later to show this.
Cool. Yeah, I think that this is one of the things that I have found so valuable in using your data in Lens, is that differentiation that goes beyond just forest, but like being able to pick up on the differences between forest and open forest and plantation forest. Obviously, that's something that if you're looking at a small area, you can often visually detect. But when you get to the point where you're trying to scale across multiple sites or understand across a broader landscape or pull statistics, that's not just being able to sort of differentiate with the human eye isn't going to get you there. And so it's been cool to play around with your data and see how much more information you can glean when you have additional categories that go just beyond basically vegetated or non-vegetated. I'm curious, just like maybe this is getting way too in the weeds, but what does it actually look like to have a human in the loop? You're running your model once, I imagine, and then your sort of ecology experts are looking at the output of that and figuring out, where the model needs to be tuned. Is that sort of what that looks like?
In partly, yes, but the human in the loop also comes at the beginning. So at the beginning, they will do an analysis of the type of vegetation in an area, the type of forest, the seasonality, the climatology, everything. And they will collect data samples that we will later use for the machine learning model. So they will collect calibration data for all these areas. And this is also really critical in countries like in the dry tropics where the seasonality is huge. So a forest might look very different at different times of the year. So the importance of the human in the loop is making sure all these changes are taken into account.
Cool. And when you say they're collecting data, are they actually going out into the field, or are they using remote sense data, but doing that sort of manual process of saying, this is my interpretation?
Yeah, normally it's a manual process of using high resolution data at different times of the year, different seasons, and collecting, those polygons to try to validate. Then they also involve, as you were saying, in reviewing the maps, reviewing the quality of the versions of the maps that we produce, and maybe providing their input of what maybe transitions have not been captured properly, what can be improved, collecting other data if necessary, until we are happy with the final accuracy assessment.
Cool. I guess that's a good point to transition into a question about validation, because I imagine that's super important. If you're calling your data audit grade, got to back that up. I think you have a slide in here about, next slide.
Yep.
Perfect. Would love to hear about how that works, because I know that's just such a critical part of this data creation process.
Yeah, exactly. So it's really important to understand the performance of the maps, not only the land cover, but also the carbon maps, and whether they are fit for purpose for what the user wants. And we take this very seriously. We assess the accuracy of our products and also its uncertainty in a very statistically rigorous way. We follow good practice as described in the scientific literature and following international standards. So we normally set targets of accuracy based on the requirements for specific use cases, but our maps typically meet more than 90% forest, non-forest accuracy.
Cool.
I have added here a squared, here you can see in green, because also we believe that accuracy is actually quite nuanced, and we are a bit experts of this nuance. So this number I'm saying 90%, we also think that that single number is not an accurate assessment of accuracy, and what we need is a more detailed analysis of assessing this metric. So accuracy can be tested in a number of ways, but the only approach that gives you a very meaningful assessment of a random pixel in a map is doing an independent accuracy assessment. Mm-hmm. So you do this by creating isolated points placed over the entire output of your map and using a statistically valid sampling approach so that you can assess the performance of each class or of the deforestation and no forest. Cool. I'm saying this for land cover, but actually we can also do uncertainties for carbon maps, or our products we provide with accuracy or uncertainty. So in the case of carbon maps, we will take into consideration uncertainties due to the allometric equations, the field measurements, and the satellite-derived tree height.
Awesome. Like maybe you have one more slide on this. I want to make sure I'm
I
not.
think I had, yes, so because this is the accuracy analysis we did for the map I showed previously of Indonesia.
Cool.
And this map, all the red dots, red brownish dots, shows all the points we assess. So our ecologists are also involved in this part. We had more than 1,000 randomly stratified points, and these are assessed blind by our ecological experts using high resolution data. And when I say blind, it's because they have no knowledge of what the map is saying. They will only see the high resolution data, and they normally have not been involved in the creation of the maps. They are independent people. And we normally have two people looking at the points in case there is disagreement between them.
And so they'll look and make their own assessment of this is forest, this is not forest, this was deforested.
Exactly. I'm showing here for forest deforestation and the stable classes, but we can do this for also the land cover maps for all the land cover classes.
Cool.
And what is actually very useful to have is a table like this that shows the users and producers accuracy. Maybe this is getting into too much statistics, and I always have them confused. But these are very important metrics to know in a map. So I don't know, should I get a bit into detail what they're saying?
I think it's really interesting.
Okay, yeah. So the users accuracy tell us if an area of the map we predict. So for example, deforestation, so how much of that is actually correct. While the producer accuracy goes the other way. So based on the samples we have collected, in this case can be deforestation, how many of those were correctly predicted by the map? So they are kind of telling you the difference. So with that, you can get the omission and commission errors. And with these values, we can see that we reach an accuracy of more than 90% in the case of Indonesia.
Cool.
I think the next slide this is related to your previous question about open source data and other projects that are there. Because apart from this independent validation, we compare them to other projects. So we compare them to the Global Forest Watch and the Joint Research Center Tropical Moist Forest dataset. So the Joint Research Center, TMF, is produced by the European Commission and tracks deforestation using Landsat. And the Global Forest Watch data that people also know it as Hansen measures tree cover loss. So it will not differentiate between forests and plantations. So here we can see that actually the comparison showed that these open datasets make more errors in distinguishing forest and non-forest and in detecting deforestation, including both, like what I said, false positives and mischanges, misdeforestation.
Interesting that the forest, non-forest numbers across the board are so much higher than deforestation. What makes it harder? Maybe this might reveal my lack of understanding of how this all works, but what makes it so much harder to detect a deforestation trend versus just doing that binary differentiation?
Well, yeah, because that's where the change happens, and deforestation is normally in smaller patches, although here in Indonesia it tends to be a bigger scale, so open source data sets tend to do good compared to other countries. But that's where things like seasonality that I was talking might play a part. So you might see that actually a forest is deforested when it just actually the leaves changing color or things like that. So that's things that can affect the deforestation, the statistics.
That's interesting. And I know you all do a lot of work with EUDR, where obviously deforestation metrics are super important because you don't want to be falsely claiming deforestation if it hasn't actually occurred.
Yes, exactly. They are critical. And even we do a lot of work with our customers that work with Vera, with the standards, and Vera also requires a specific accuracy of the maps. So we always make sure we accomplish that.
Cool. I guess that's this is almost like a nice transition to a question that I think is always super important, especially with people who are not remote sensing experts, but are just thinking about, how do I incorporate this into my day-to-day workflows, which is like, how do you consider all of these options? I mean, you have 3 laid out here. all of which probably have moments where they're the appropriate choice for use, and would love to just hear your advice, like taking off your space intelligence hat for a second. But if someone's sitting down and thinking about, I want to answer this question, like what are the steps that they can take to try to understand where space intelligence's data is really important for use, where something like global forest loss or the tropical moist forest layer might be appropriate. And I guess sort of like, what are the questions that one should ask themselves when thinking about that?
Yeah, I mean, it's a very good question, because it's true that there are more and more data sets every day out there. And I think this is a great thing. Me as a scientist, I really like this, and it's amazing for conservation and for forest protection. But I understand it can be very overwhelming and challenging. I think it really depends on the use case. So I think people should just try to think properly about their objectives and should be aware of the advantages and limitations. I think you call them promises and pitfalls. And
Yeah.
Yeah. So yeah, you should consider key things, which could be, I don't know, temporal resolution and spatial resolution, coverage, thematic definitions, like does it follow the definition you want to use for your forest, and as well as the accuracy of the product and whether the product has transparency of how it was created. I think as you said, I have showed two of them, two of the global products widely used by everyone. And I think these are great products and can be very useful in specific cases. For example, larger scale comparisons or monitoring a large scale, creating a first quick screening of a project. However, you have to understand what their limitations are. Specifically, these products tend to be global or regional, so they are not calibrated locally. And what happens is that global models tend to generalize across ecosystems. So this can lead to misclassifications and systematic biases for a specific area. So if you have a local level, you have to understand how these products are performing there.
Yeah.
Also, some of these, I was going to go into my remote sensing hat on, because you have to also, if you have this knowledge, understand how these maps were created. Because some of them, for example, two we have here, might be created with optical data only. And this can have problems in some countries. For example, many of the forest conservation projects are in the tropics, which have a huge cloud cover. Some areas are covered by cloud more than 90% of the time. So a satellite bus might just miss it and not see it. So using a combination, or a product that uses a combination of optical and radar, might increase the accuracy of them.
That's definitely something we've experienced, where sometimes you're looking at sites at the satellite data and there's just nothing available for months at a time because of clouds.
Yeah, it's very challenging in many places that, for a whole year, you might not have any visibility of it. So you have to source to other things. So radar is great for that.
Cool. I'm seeing questions coming in, and I want to make sure we leave lots of time for questions. So I'm going to transition over to just quickly showing folks what this data actually looks like in Lens. And for current customers, this will be helpful if you want to access this data. I can show you quickly how to do it, but it'll also be just kind of a nice preview for how this all works. So let me switch over for a moment. So this is the Lens platform. It is a web-based geospatial tool that's meant for monitoring and management of land. It's area of interest based. So you're basically loading in whatever areas you're wanting to monitor for. So compared to the maps that were in Paula's slideshow that were sort of like country based, we're really focused on sort of the project scale. So how do you monitor at that sort of project or regional scale in a way that's efficient and allows you to answer the questions that you have? Our customers just load their areas into Lens. So you can see, you can upload from a shapefile. You can also just draw an area on a map. Paula had mentioned early diligencing is one of the use cases for space intelligence data. We try to make it as easy as possible to just get in there and start looking at the information that's available. And then we work with a whole bunch of different providers, space intelligence included, to pull in lots of different types of relevant remotely sensed data that could be helpful. So that can be things like chlorophyll information for water bodies, land cover data, vegetation, carbon, and the space intelligence data is in here, and you can request to order the data via our platform. Because of the way that space intelligence creates their data, which is human validated, it's almost like what we call a tasking model. So if you're familiar with tasking a satellite, that's where you basically custom order imagery from a satellite. It's the same story with space intelligence. You're basically custom ordering the data for the particular areas that you want through our platform. And this is what that data looks like. So right now we're looking at a site in Cameroon, and this is a site that has been experiencing deforestation as a result of illegal gold mining. So you can see here, this is an image that we're looking at right now from 2020. That's a Planet NICFI image. And then if we go over to 2025, this is a more high-res image, but we can see that sort of significant expansion in terms of the impacts of this mining operation on the landscape. Visual is super helpful, right? We can get a sense for what's going on the ground, but we can't necessarily quantify those changes. And that's where the space intelligence data can become really helpful. So this is a note that we've created in here that basically appends a graph showing space intelligence data. I can turn on the visual representation here so we can see those classes that Paula was talking about. In this case, I think there's 10 classes on this site, from dense forest to open forest, plantation, urban and bare land. So really getting down into the detail in terms of that level of differentiation. And we can visually see how this site has changed over time, but we can also run an analysis. So I'm going to run an analysis using this land cover data. And you can see here, I can now pull up the quantification associated with this. So back in 2020, within this boundary area that I drew, 450 acres were considered open forest, and that dropped down to about 400 acres. Same with dense forest. I'm seeing that's probably the area where there's been the most significant change, about 400 acres. And I can ID, how that change has transitioned to another land cover type. So we can see, shrub and urban and bare forest has grown at the same time that those forested areas have been lost. All of these statistics can be pulled out via CSV if you want to create your own sort of visualizations or compare it to other, ground truth data or things like that. And you can also clip this data to just the particular categories, which I think is cool. So for example, if I'm just interested in seeing, what are the areas that are classified as dense forest on this map, I can turn on this clipping tool. I can also clip this geometry so you can actually pull that shapefile out and use it elsewhere if you just want to see, back in 2020, what was the actual footprint of the dense forest on this landscape. So the space intelligence data plays really nicely with Lens, and I think it's exciting just sort of how these two tools can come together to make it super easy to pull out these kinds of statistics or identify changes that are relevant for really, I think, a whole bunch of different markets, from forest carbon to conservation to EUDR. I mean, there's just like such a broad range of ways in which this data can be leveraged. And then the last thing I'll just quickly show you is you can create change detection policies based on the space intelligence data. So if I go in here, this is our change detection policy creation tool. I can select land cover for space intelligence, and I can select which pixels I want to be notified if they're changing. So for example, if I want to know when dense forest changes into any other one of the classes, I can turn that on. And then every time new space intelligence data becomes available in the account, it will automatically basically draw polygons around the areas where that change has occurred. And you can have it actually set up to do that automatically, where it sends you an email. So you're not necessarily having to log in and do things within the platform, but you're finding out if there's a particular shift that is important to you, which I think is really helpful. I mean, obviously you can create change detection alerts on lots of different types of data. You can do it for NDVI. That's not necessarily getting down to this level of detail. Maybe you only really care about a transition from sort of ecological dense or open forest to plantation forest. And so you can drill down and make sure that the alerts you're getting are specific to the kinds of questions that you're trying to answer. So I'll pause there. Paula, welcome any comments or additional context you want to share about your data, just having seen it in this format. And
I
otherwise,
think it looks great. It's great to see it in your platform. It's a really visual also example, lots of change there. So
yeah, this one's fun because there are so many different colors and there's a lot happening here. I shouldn't say fun. We're not excited about deforestation lost by mining, but so we just have a few minutes left. I'm gonna just make sure that we get some questions answered from other folks who dropped in the chat. So we have one question, which is the high resolution data that you use for validation higher resolution than the satellite data you use for the classification? And do you have full coverage, or is it temporally consistent, as deforestation is sensitive to time lags? So actually a couple questions in there.
Yeah. So the high resolution data we use to validate is independent of what we used for the model. So normally we use much higher resolution data, like for example, from Planet, to validate our maps. We might also use images from Sentinel, things like that we also use for the creating our maps. But for our maps, what we use is open, accessible data, satellite data that it's out there. And we don't use very high resolution data. We just use that for the validation.
Cool. Perhaps a sort of similar question, but how do you address the trade-offs between spatial resolution and temporal frequency when you're generating your maps, particularly in dynamic ecosystems like Indonesia's rainforests?
Yeah, so yes, it's a trade-off of what you want to use. And for some use cases, you might not need a huge spatial resolution. So we do our maps with 10 meters. This is also because of the input satellite images that we use. But we think 10 meters is great to kind of detect the different types of vegetation in an area. So if you go to a higher resolution, you might see a tree, but you will not have the context of whether that tree is in a forest or just is an isolated tree. So it's a bit of trade-off as well. The temporal resolution, land cover maps, we normally do it annually, so annual land cover maps. But as I show, we also have this new product that is degradation and deforestation monthly alerts. So we provide those too. For carbon maps, we normally do it either annually or every 2 years, depending on the use case. But it's also because carbon, apart from the deforestation, that will change all of the carbon, but it doesn't grow or increase so quickly. So we think annual is good enough.
What are the biggest challenges in mapping degraded forests versus intact forests?
Degraded forest is much more difficult to map. It's degraded and also like complex mosaic forest or dry forest, and that's where many of the open data sets perform worse. Mapping a dense forest, you can see it like using Google Earth, that if you see it all green, it's very easy to detect if it's a forest or not. However, if you start to go into more degraded forest, you don't know actually looking at an image if it's a shrub or if it's a tree. So forest definitions might state the height of the tree that it has to be, or the canopy cover, whether it's a specific threshold. So different countries have different forest definitions, 10% or 30%. So differentiating between that, what is a degraded forest, but it still fulfills the forest definition or not, it's a bit more tricky to balance.
Yeah, that totally makes sense. I do think one of the cool things about Space Intelligence's data, which you sort of touched on but didn't linger on, is that you all match forest definitions to the regions in which you're creating data, which is not always the case, which saves people a lot of time if they can just sort of know in accessing your data that the definition of forest is the definition that they need to use.
Yes, exactly. And there are things like tree crops that many data sources might map as forest, but it's actually agriculture, it's a tree crop. And this is actually really important for uses like EUDR, whether it's coffee or cacao, and it's actually not forest. So it's going into that detail.
Cool. I know we're over time already, so I want to close out with one final question that I am submitting to the Q&A box, which is, what are you most excited about in terms of tech on the horizon? Are you all working on anything super cool and new, or where do you see this space going? What's next?
So I mentioned the degradation mapping, disturbance tracker we call it, which is very exciting. But as well as you flag, we are working with EUDR. So all this working in supply chain monitoring, I think is very exciting, and I think it's very important because agriculture is one of the main drivers of deforestation. So by properly mapping these transitions, this deforestation, and monitoring the supply chain, I feel it's critical.
Awesome. Well, Paula, thank you so much for joining us. This was really fun.
Yeah, thanks for inviting me. Great.
We didn't get to everyone's questions. If your question is burning, both of our emails are up here. Feel free to reach out to us and we can answer those offline. But yeah, thank you everyone for joining us. It was great to have a conversation with Paula and share a bit more about Space Intelligence, which is a company that we think is doing super cool work. So thank you. Nice to see you. And I hope everyone has a great day.
Thank you, Eve, and thank you everyone for attending.